So far I have really only used the hardware controls as AMS sources, so let's see what other modulation sources there are. I'm going to start with the amp EG. Now this is a control that can be set as an AMS source, and when it's set it automatically changes the volume of a sound as it is playing. Now you could press a key and you could control the volume with a volume pedal or with the volume knob. But suppose you want repeated changes in volume that are exactly the same every time you play a note. Volume changes with a foot pedal or with a volume controller might not be particularly accurate. And of course, if you're using one hand to control volume, you've not got two hands free to play the keys. If you use a foot pedal, that foot pedal's controlling volume when you might want it to control a wah-wah effect. So we'll use an amp EG effect instead. So what's an amp EG? Well, every note you play will have what is known as an envelope. When you strike a note on a piano, for example, the note you play will fairly quickly reach a peak of volume. It'll then drop very slightly, or decay, and then it'll start to level out, sustain, and then die away. Now the shape that I've just traced is the volume envelope. You might hear it referred to as the amp envelope. So an amp envelope is short for amplitude, and it's simply how loud the volume of a sound is from the start to the end of the note you play, and how that volume changes between the point of the note starting and finishing. Now the electrical components used to control this amp or volume envelope and make sounds produced by the synth's oscillators louder or quieter are known rather logically as envelope generators. So when you see amp EG controls, this is basically an amp envelope generator that you can use to control the note's volume automatically. So in very simple terms, it's a volume control that you can program to operate hands-free. While you could change a note's volume with a volume pedal or even with a volume knob, if we can program the synth to do it automatically and design different amp envelopes, we can have sounds that are really dynamic and have both hands free and feet to play and add other effects. We can create amp envelopes to change the volume of a sound automatically, but we can also create pitch envelopes and tone envelopes so that pitch and tone can be made to change from the start of the sound until it dies away, and controlled independently and automatically. We'll discuss the other envelopes shortly, but let's see how useful the amp envelope generator could be as an alternate modulation source, because we can use it in such a way that other settings can be made to change and follow the changes to the sound's volume. Now, a piano chord like that has a very basic 4-stage amp envelope, and these 4 stages are referred to as attack, decay, sustain and release. The attack phase of the note is the time from striking the key to the point that the sound is at its loudest. The decay phase is the time from the end of the attack period where there is a slight drop in volume. The sustain phase is the portion of the envelope where the sound levels out before it finally dies away, and where it dies away, that's referred to as the release phase. This attack, decay, sustain and release, or ADSR envelope, is something which can be controlled by the synth. So we could set a longer attack time, and we could have the note swelling gradually like a violin, or we could have a sound with an immediate attack, a long sustain and a very short release phase. That would be very characteristic of an organ. And a rapid attack moving straight from the point of impact to the release phase would give us a characteristic snare drum. So as we can see, we can have more than 4 phases, but the complexity and the number of these settings is typically dependent upon the price of the synth and its age. However, if we can control volume, pitch and tone envelopes, we can create sounds that change massively and automatically and accurately while we simply depress a key. AMS is important here because we can create these envelope settings for a sound, and we can use these envelopes to act as AMS sources and get other controls to follow them, or we can adjust them on the fly with other AMS sources such as pedals, the mod wheel, etc., to create some really dynamic moving sounds. Now we can use these envelopes as AMS sources so that other parameters such as pitch will follow them automatically, and you could have a pitch, for example, that follows the volume so that it's changed by the amp envelope and goes up and down, and also you can use it to control a filter so that the filter changes, creating different tonal characteristics, and all of these things following the straight line created by the amp EG, which is changing the volume. Now a lot of sounds that occur in nature have the basic ADSR volume envelope, but think about a saxophone or a trumpet or a flute or an oboe. The player can adjust the volume by blowing harder or lighter until he eventually runs out of breath and has to stop. So while there will always be an attack and a final release phase, there could be quite a few different changes in between. Now a drum will have a faster attack than a violin, so it will get loud really quickly, whereas a violin may take much longer to reach its loudest point. So although the basic 4-stage ADSR envelope I've just spoken about will be seen in nature and heard regularly, as in the case of the piano, but most synths, including the Korg Kross, allow you to create and adjust basic ADSR envelopes, and these envelopes may have more than 4 phases, and really complicated synths will allow you to set up different envelopes to create some really interesting sounds, so that you make it much easier to impersonate things like horns, strings and voices. Right, let's look at this in practice. Go to the P pitch page for the unison square lead by pressing the menu key and scrolling down to P pitch. At the bottom you'll see the AMS setting. Change that to amp EG and set the amount to +12. At this stage I've set a pitch change of an octave, and I'm using the AMS setting of amp EG to control it. So what we need to do is to add an amp envelope or a volume envelope that will control the rise and fall of the pitch. And to do that I'm going to go to the P amp EG page, and you'll notice that on the left hand side you've got a number of controls: attack, decay, sustain, release. Now there are a couple of additions in there. One is the BRK, which is break, and the other one is slope, and they're allowing additional phases within that basic 4-stage envelope. So it's actually a 6-stage envelope. But at this stage what we're going to do is create a typical ADSR envelope for this particular sound. Now you can see the graph on the right of the screen, and that is showing the shape of the ADSR envelope. And what I'm going to do is I'm going to set the attack time to about 72, 73. And you can immediately hear the pitch climbing as the sound raises in volume from its lowest setting to its highest. Now if I set the decay to, what shall we set that to? Let's set the amount to 78. Now you'll notice that you've got a slope upwards, a very quick drop to the sustain phase, which I'm now going to set at 78 as well. So the sustain phase will level out, and I'm going to set the release to 99. Classic attack, decay, sustain, release, and it sound like this. Attack, decay, sustain, release. Now you'll notice at this stage that I've taken my hands off the keyboard. So the release phase is the time from the end of the sustain phase to the point at which that sound dies away. The release can correspond with the release of the keys, but it doesn't necessarily have to. At the top of this page, you'll see a reset AMS control. Set this to SW2 or switch 2 and set the amount to plus 99. Now if you play a note and press the switch 2, what you'll note is that the switch is effectively resetting that envelope to the start point, so it starts again. This is a neat effect, and it's a handy little control to have.